Okay, we're on the last part, 1.47 complex solutions. And I'm going to show you guys a couple of ways to do this. Let me show you guys the textbook way. So, method number 1, textbook. And the problem is x squared, let's do it maybe over here, x squared equals negative 144. And we're doing the same thing, we're solving this by factoring. And I want to show you that if you add 144 to both sides, you get x squared plus 0x plus 144, and then you would try to use your Xbox method, and then you would do something like a times c is 144, and then a b value of 0. Now pay attention, you couldn't do 12 and negative 12, because although that adds to be 0, that would multiply to be negative 144. So our method of factoring here does not work. So the textbook says, alright, the textbook would say add 144 to both sides. And then I have x squared plus 144 equals 0. And then you change the 144 to opposite of a negative 144. And the reason why they're doing this is so that you can do, this is going to be hard. How do I multiply two identical numbers to equal negative 144? We just talked about you can do 12 and 12 or negative 12 and negative 12, but you can do something. We can call in the pirates. Let's call in the pirates. Let's call in the pirates. So you can do negative 12i squared. Okay, what does that equal? That equals, so negative times a negative is a positive. 12 times 12 is 144. And I times I is I squared. And remember, what do the pirates say? I is square root of negative 1, or I squared is equal to negative 1. So if we remember this information, then we can say that's negative 1. I meant to do that in pink. And negative 144. Okay, so that means that I can put in here negative 12i, or there's a second one, I can choose positive 12i. That would equal the same thing, right? 144 gives me I squared, and then I squared is negative 1, and I get negative 144. Okay, so the one I'm going to choose is I'm going to choose the positive 1. So now I have parentheses x squared minus parentheses 12i squared equals 0. And the reason why I want to do that is so that I can use the formula difference of squares, which I showed you. And the formula then is a plus b, a minus b. I told you I don't like memorizing formulas, but I have not seen a way to figure that out by using the Xbox method of factoring. So if you know it, let me know, and we can do it. Okay, so my a value is now x. Let's get the right color in here. And my b value is 12i. So b value, 12i, and then you kind of go through in here. So what we've done so far is we factored x squared plus 144. Let me highlight that for you. We factored it here to equal this, okay? And then now we just need to solve it. I can solve this by setting it equal to 0 and subtract. You get x equals negative 12i. And then over here, we do the same thing. Add it to both sides. You're going to get x equals 12i. So basically it equals positive negative 12i. So that is the textbook way of getting a solution by factoring. Okay, let's go ahead and show you guys my method. And it is faster, but I gotta say it'll give you the answer, but it's not using factoring. So if you were doing a free response quiz or test for me or another math teacher and it tells you to do it by factoring and you still get, you don't use factoring like this method I'm going to show you, because what I'm doing is I'm using the square root method. And just pretend you're becoming a cook and they say cook the potato by baking it. And you boil it and you're still getting a cooked potato, but you're using the wrong method. And that's the same thing here in math. So let me show you what I'm talking about. So I have x squared equals negative 144. And you can show the work, but I'm saying you're kind of using an indirect way of doing this. Just sometimes okay. Okay, so the square root method says once the x squared is isolated, I'm going to take the square root of both sides. You're left with x equals, now you have to do the plus or minus, the factors of negative 144 and negative 1 times 12 times 12, right? And then the square root of negative 1, that becomes your I on the outside. And then you have a pair, so those can come out. So our answer is x equals plus or minus 12i. Now, I want to show you guys how fast that was comparatively. Here's my solutions here, and here's my solutions there. So essentially I have the same answer. Now, if they ask you to factor it first, you can just do this. Now that we've done the problem with the square root method, you can say add negative 144, move the negative 144 to the other side, so you have this. Okay, we haven't talked about this, so this is a little bit more advanced. And I'm going to show this by colors. That's hopefully you guys see why I do colors. Okay, so what I'm going to do here is I'm going to put in here each of these. And what I wrote there in the white formula is for x-intercepts or factored form, which we are actually talking about. So one was a positive 12i and one was a negative 12i. Okay, so then you'll get x minus 12i and x plus 12i. And what I'm trying to prove to you is, so if you're doing that super clean on a quiz or test, you have x squared equals negative 144. So I'm kind of doing this from the beginning. You would add both sides, x squared plus 144 equals 0. And then you would use this, what we just did right here, down here. So then this is, I'm showing that you factored it. Most math teachers are just more concerned that you know how you got these binomials, or just that you have the binomials. You can use guess and check, tic-tac-toe, you can use my Xbox method. Does that make sense? And then you can just say that the answer is 12i and negative 12i. So down there, hopefully that was, that's my method. It's kind of indirect, but you still get the answers. So as you do the next couple of problems, you can choose which method you want to use. As you can see, both methods give you the same solution. You can also show the factored form. And I'll probably go, let me show you guys, 27 to 29, I'm going to use the textbook method. And then questions 30 to 32, I'll use my method. For 27 and 29, go ahead and complete 2, and then you can go ahead and do press play to see the solutions. All right, let's go ahead and use the textbook method here. I'm gonna write this above so I don't forget. Textbook. And really it's not my method, it's the square root method. Okay, for number 27, let's move this to the other side. So I now have x squared plus 25 equals 0. In order to use the difference of squares, we have to change it to subtraction. So how do I do that? We do minus, minus. So now I have x squared minus negative 25. I'm sorry, that is wrong. It's I guess I skipped a step. Sorry. X squared minus minus a negative 25. And then if you want to, we have to kind of take the square root of both x squared and 25, which gives you the negative 5. And I forgot the negative, the I. So let's double check that really quickly. This one should not be. Okay, so let's double check. I'll do it over here on the side. Negative 25, is it equal to 5i squared? And 5 squared, and then you have I squared, right? So that's 25, and then I squared is negative 1. And that is true. What? Negative 12, negative 25. Now, if you get stuck on this part, let me show you another method that you can do something like this. Negative 25 equals x squared. You're solving for x, and that's what goes inside the parentheses, if that makes sense. So if I take the square root of both sides, you're going to have x equals plus or minus. You have to write that every time you do the square root of an equation. You solve an equation. The factors of negative 25 are negative 1 times 25, so the square root of negative 1 is I, and the square root of 25 is 5. So in some ways you have two answers to put in there, but we talked about in the do it with me problem that I want just the positive 5i. Let me write that in blue. And the reason why I want that is so that I can have it in this form. I always write down the formula, super helpful for me. And this is, if you can see that this is called the difference of squares. Does that make sense? Let me highlight that. Difference of squares. And the formula I need to write for that is a plus b, a minus b. So the a value, let's just use some, a value is going to be now x. Okay. This thing's too big. The b value is 5i. And then we can just go back and fill in everything. So x plus 5i, x minus 5i. And then just set it equal to 0, zero product rule, and this is where now, so that's factored right above, and now we're just setting equal to 0 to solve. You do the opposite to move it across, and then you have this as your answer. Okay? That is solving number 27 using the difference of squares. Let's try number 28 with difference of squares. It's already set equal to 0. I'm going to change this to a minus. Pencil work. Okay, so alright, so I need something in here, and what you can do is, what am I going to put in there? Right, so you can do negative 100 equals x squared. No, we shouldn't use x. Let's use w. Does that make sense? The pink one is parentheses squared, so I'm calling that w squared. I take the square root. You must have a plus or minus. So square root of negative 1 times 100. And then the square root of negative 1 is I, and square root of 100 is 10. So you have plus or minus here. And we talked about how you're going to just take the plus. So you're just going to write in here 10i. 10i squared is equal to negative 100. 10i squared is equal to negative 100. That'd be 100, and I squared is equal to negative 1. Does that make sense? Okay. And then this is your x. Then your formula, you have a squared minus something squared. And the formula is a plus b, a minus b. And if you actually multiply a plus b times a minus b using float or the box, you will get the expression above in blue, dark blue. Okay, so my a value is x. So writing a, we're writing x. And instead of writing b, we're going to be writing 10i. 10i. Okay, so then I fill in everything else. And then we just separate and solve. Set it equal to 0. So x is equal to negative 10i and positive 10i. Alright, number 29. We're going to solve this one by using the textbook method of difference of squares. And I'm going to add 225 to both sides. Remember, you cannot get 225x squared because they're not in like terms. It's like saying Pepsi plus Coke equals Pepsi. Like 2 Pepsis. It's not right. You can say 2 sodas, but you can't say 2 Pepsis. I'm wearing a Coke shirt. I like Coca-Cola. So x squared plus 225 equals 0. We've been changing this plus sign to minus minus. Why did I do that? We're trying to find something squared minus something squared because this is the formula. A squared minus b squared equals 0, and that'll turn into a plus b, a minus b. So I guess you can call it b squared equals negative 225. And you're going to take the square root of both sides. Try to make this clear, clear, clear. Every time you take the square root, you must have the plus or minus. B equals, that is negative 1 times 225, so that would become I, and the square root of 225 is 15. So although this is your answer, for this problem we're just taking the positive. You could take the negative, but so that means that becomes 15I. That one becomes x squared. So that means every a value is equal to x. Every b value is going to be 15I. So I have x plus 15I and x minus 15I. Separate them, solve them, you're done. And that's our answer. All right, questions 30 to 32. I'm going to go ahead and use my method called the square root method. You could use the difference of squares if you want to, but I'm going to show you guys. It's going to go really fast. So subtract 4, x squared equals negative 4. And then I'm going to take the square root of both sides. This is going to be x equals, remember you have to have plus or minus when you do the square root of an equation. And then this will be negative 4. So that is negative 1 times 4. X equals plus or minus, square root of negative 1 is I, square root of 4 is 2. So this is the answer. So if you were doing this problem to kind of show that you're factoring, you can do this. Now you'll notice that this is not the formula for difference of squares. This is the formula for factored form, or x-intercept form it's called. That's what we're kind of working on. And now I'm going to do that for each one. One's positive and one is negative, right? Because it has plus, it has minus. So that's my factored form. You can clean that up. And then you just do the same thing we just did. Separate it, set it equal to 0, and solve. Remember, that just means two solutions, right? It just means 2i, negative 2i. Okay, so that's using the square root method to kind of, the blue side is what you kind of need to show that you're using, quote unquote, the factored form. The left side is the square root method. Let's highlight that. This is just using the square root to find us the solutions, but over here in blue, this is showing the that you're kind of quote unquote showing your work for factored form or factoring. Okay, let's try 31. We're going to use my square root method, Mr. Ng's method, solving this problem. Okay, this one, I wanted to say x squared equals, so I'm going to divide both sides by 36. So that's gone. So you're left with x squared equals negative 25 over 36. Okay, I'm going to take the square root of both sides. Remember, when you take the square root, you have to have plus or minus. So that becomes x. The reason why that works is there is like a invisible 2 right here. In some ways, this 2, and the radical sign are gone. So it's left with x. Okay, this one, I'm just going to break it up so you can see it. This is going to be the square root of negative 1. I didn't know this, so that's what I'm trying to show you guys. This is the square root of 25, pay attention, and the square root of 1 over square root of 36. And the reason why I chose to show you that is that all of them are under the square root, the negative, the 25, and the 36. So I have square root of negative 1 is I. The square root of 25 is 5, which you'll notice is in the top of the fraction. And the square root of 36 is in the denominator. Square root of 1 is 1, so we just keep that up there. And then the square root of 36 is 6, but it's in the denominator. So here is our answers. Let's go ahead and plug that into factored form. So if I was showing the work here on the right hand side, I would add 25 to both sides. Now I'm going to use the factored form. Come on, come on. Okay, so that's just using my solution, right? 1 positive and 1 negative. And you'll just clean it up. Separate it, set it equal to 0, and solve. Do you want to see that? Sure. So again, the blue side, I'm trying to show you like what it would look like if you're showing kind of like I'm factoring this to solve. But we use the left side using the square root method to kind of show you how I got positive and negative 5i over 6. Then you would just subtract both sides and get x equals negative 5i over 6. Ta-da! Okay, number 32. Again, we're kind of showing you using the square root method. And then the square root method gets our solutions, and we use the solutions to go back to factor form. Or you can use the difference of squares formula. So I'm going to divide by 64 to isolate. So that equals 1. So I'm going to put x squared equals negative 49 over 64. I'm going to take the square root of both sides. When you take the square root of both sides, you must have a plus or minus. So you're left with just x. And everything is in the square root. So remember, this is a square root of negative 1. So that is I. The square root of 49 is 7, which is the numerator or top of the fraction. And 64, square root of 64 is 8, but the 8 is in the denominator. So these are my solutions. And I'm going to use that to put it back into factored form. So let's work with orange. So again, if you were showing others how to factor, most people are not going to ask you, how did you get these binomials that we're working towards? They just kind of want to know what goes in these binomials. And remember here, when I'm doing this, this is not the difference of squares formula. This is the factored form, which is the whole lesson. So let's put here in this white box, I have positive 7i over 8 and negative 7i over 8. Let's go ahead and clean this up. Wow. Eraser. Notice my fractions are running up and down, not sideways. And then you just set them equal to 0. 0 product rule. and solve, and you'll basically have what we had previously, right? Positive 7i over 8 and negative 7i over 8. Okay, so the work on the orange is showing you that it's looking like to others that you factored, if that makes sense. And that was, remember, you don't have to do the end of these, just optional, or I don't know, when you want to challenge yourself. So that was lesson 1.4, solving quadratic equations by factoring, where you can check your, we didn't check our answers for those bottom ones. Let me check one. Let's just do this one. 64 times 7i over 8 squared, does that equal negative 49? And 64 over 1, 7 squared is 49, I squared is negative 1. And this is 64. So 64 divided by 64 is 1, so you multiply that as negative 49. And if you chose to use negative 7i, it's saving image, I don't know if you can see that. Negative 7 times negative 7 is 49, I squared is negative 1. And then 8 squared on the denominator is 64. And then you can just cancel, negative 49 equals negative 49. So I didn't do checking for all, please save it, I'll be upset. Just didn't save the last part. But hopefully that was helpful. We'll see you guys later. Bye.
In the class of 2010 of trigonometric, Mr. Ing, we learn about quadrant first to the fourth. Oh wait, that's our ground one stuff. We learn about trigonometry in this class with who? With Mr. Ing.